Hey, in this video, I'm going to teach you how to solve acid-base titration problems. And if you recall to my last video, which I include both stoichiometry and the MV equals MV formula way to do this type of questions, it's on my playlist, acid-base equilibrium, and it's on the second video. If you want to take a look at this, you may. But for this video, I'm going to show you the problem that you cannot apply for the second method, which is the formula one. And I'll show you why later, but it's simply because the reactants does not have a one-to-one ratio, and it's a key point for you to apply for the second method, which is the formula one, but it doesn't work in here. Okay, so I'm gonna show you step by step and help you walk through this question, and hopefully in the end of this video you may understand how does it work. Okay, so let's start. It says, in a titration of sulfuric acid against sodium hydroxide, 32.20 milliliters of 0.250 moles of, molarities of sodium hydroxide is required to neutralize 26.60 milliliters of sulfuric acid. Write the equation and calculate the molarity of the sulfuric acid. Okay, so for all of the titration problems, the first thing you have to do is write out the balanced equation. Okay, so it's very important. And for this question, it's also given to us, like you have to write out the equation. But even though it didn't ask you for it, you have to have it for your further calculations and analysis. Okay, so let's do that. So it's given to us two reactants in here, sulfuric acid and sodium hydroxide. So let's write this out. So it's going to be H2SO4 plus NaOH. And also a very key concept in here for the titration, 99% of the times it's going to give you one acid and one base, and the key point is just using them as your reactants and write out the products that they're going to yield to. So what is going to yield to? So one of the products is always going to be water. Okay, so it's also a little trick that I help myself to do this type of questions, is that I will write out the water as the product first, and then I will take a look back at the reactant side, see what's left over like after I produced a water molecule. So what's been left over right here is gonna be Na2SO4. Remember to balance this out, always important. Okay, so let's balance this out. So we have two sodium ions in here, but we only have one. So we have to add a 2 in here. And after we add here, like it has 2 oxygen and 2 hydrogen, and there's 2 hydrogen in here also, so it's total 4 hydrogens. And then in here we only have 2, which means that we have to have 2 in here, which means 2 water molecules. Okay, so this is our balanced equation. Let's start by solving the molarity of the sulfuric acid. So a very key hint in here, if the question asking you for whatever the molarity of or the volume of one reactant, always start with another one, because for most of the cases another one have more information, and you really want to start with the one that you have more information with. And in here it's going to be sodium hydroxide, and we always want to solving with starting from the volume, because it's easier for you to convert do the conversion later. So I'm gonna start with the volume in here. The volume is 32.20 milliliters. I think it'll be easy to do the liters instead. So I will change it to the liters, which is gonna be 0.03220 liters of NaOH. Okay. And then we want to change it to moles, right? Because we want to apply the mole ratio in here. But how do we do it? It doesn't give us any moles. Well, it given to us the molarities. And what does molarities means? It means the moles divided by liters. So instead of writing like this, we can write it like this. Okay, see? And what's the purpose of me doing it right here? Well, I think you will see that the liters in here is going to be cancelled out. Really cool, isn't it? So then I'm going to use the mole ratio. And also at this point, I think you can see it right here, is that two moles and 1 moles, they're not 1-to-1 ratio. And that's the reason that we cannot use the formula MV equals MV in this question. And instead I'm going to use the stoichiometry, and this is our only option and only solution in here. So it's going to be 2 moles of NaOH with correspond with 1 mole of sulfuric acid. H2SO4. Okay, and then let's do the calculations. So it will be 0.0161 mole of sulfuric acid. Okay, so we're halfway done. And the last thing is just do the molarities of the sulfuric acid. Well, for knowing the molarity, we have to know the volume, because we have to use the moles divided by the volume to get the molarities. Well, what's the volume? Well, take a look. Volume is in here, 26.60 milliliters. It's easier for us to do the liters, so I'm going to use the liters. It's going to be 0.02660 liters of H2SO4, which is going to give us 0.605 moles of sulfuric acid, and we are done, right? It's not that hard, and I think the process for the MV equals MV, it's definitely going to be longer, but it's also really fun, I think, because it's kind of like your logical chain has been linked like step by step as you walk through this question. And let's just summarize a little bit right here. So for the titration problems, always start with the balanced equation. And I think even though you can use the MV equals MV formula for some cases, but most of the titration problems, they won't give you 1-to-1 ratio for the reactants, for the acid and base. So I think it will be a lot more safe, and also it's fun for you to just do the stoichiometry in here. And always remember, starting with the components with the most information that you know, like that the question given to you, which in here is going to be sodium hydroxide, and then you're going to convert it to the moles, and then use the mole ratio. And where can you find the mole ratio? It's always right here. It's always going to be the balanced equation, and that's why it's necessary for you to write out the balanced equation for titration problems. And then if it's asking for the moles, then you're done right here. But if it's not, then you may want to do a further step for you to convert the moles into molarities or like anything else, and then we can get our final answer. Okay, so yeah, so that's the question for the type of titration problems that does not given to you like the 1-to-1 mole ratios. You have to use the stoichiometry, but I think it's also very interesting. So yeah, so I think that's all for this video, and also all type of formats for the titration problems is covered completely up this point, because I don't think it's gonna asking you even more with this. I think most of the questions is just gonna giving you like this format and require you to do the stoichiometry and conversion. So I think that's all for this video. Oh, and also a very key point to point out before we end this video. What is sulfuric acid? It's gonna be a strong acid, yeah. And what is sodium hydroxide? Strong base, yeah. Remember these like strong acid and strong base, you have to remember them. It's just things that very worth to remember, and it's also useful for you to do all of the calculations and the further chemistry analysis areas. Okay, so that's all for this video. I hope you learned something from it. If you like my video, please subscribe and leave some comments below. I would like to hear your thoughts, and I hope you have a nice day. See you next time.